Good morning. My name is Vincent Altabello, and this is my implementation plan analysis for applied decision making from American Public University, instructed by Dr. Alec Alazo. For this project, Starlink, powered by SpaceX, was chosen to review for potentially developing a new product for their Starlink mini line. SpaceX is the leading space exploration company in the private sector and even takes astronauts to the International Space Station for NASA. Starlink uses an array of globally orbiting satellites that send signals down to receivers on Earth, which then provide the individual users with access to the internet. All that the Starlink requires is to be plugged into a 110-volt outlet. For the Starlink Mini, there's a built-in router, so no other components are needed at all to access the internet. The problem, though, is just like with any other satellite signal, you need a clear view of the sky. Through the Starlink cellular telephone application, the receiver will show the user where the obstructions are and where the clear view of the sky is. Fortunately, only a clear view of the sky is needed. With the Starlink Mini, the largest market is those users who would use the system when they are predominantly in a vehicle traveling in areas where there is no cellular telephone service, which creates a problem for those users who want to mount the system inside their vehicle. Unless the user has a sunroof with only glass between the receiver and the sky, the signal is obstructed and greatly degraded, if it even works at all. So according to ChatGPT, the published number of Starlink users worldwide is 12 million people as of June 2026. Further inquiry into ChatGPT revealed that there are no published numbers from SpaceX that indicate the type of hardware that its subscribers are using, whether it be the residential device or the Starlink Mini. ChatGPT indicates that there are estimates that indicate that the number of Mini users is in the hundreds of thousands, as the device is a niche item developed in 2024 and geared toward adventurers and people who travel often but need to stay connected. Estimating that Mini users could potentially be in the 300,000 ballpark, Microsoft Excel was utilized to calculate that this is approximately 3% of the total number of Starlink users. Obviously, there is no way to estimate the number of Starlink Mini users that have the device mounted inside or outside of the vehicle, or the number of users that deploy the device only when they are stationary. However, one number that can be estimated is the number of YouTube creators that participate in an activity called overlanding. Overlanding is self-reliant adventure travel to remote destinations where the journey is the primary goal. According to ChatGPT, there are approximately 10,000 creators on YouTube whose primary focus is on overlanding. This number represents approximately 3% of potential Mini users worldwide. According to ChatGPT, approximately 20 to 50% of Mini users mount the device inside the vehicle. So according to ChatGPT, the signal receptivity of the Mini is severely degraded when passing through the roof of a Jeep Wrangler hardtop, which is the most popular overlanding vehicle in the United States and the second most popular in the world. Keeping this in mind, SpaceX would need to conduct their own tests to see how well or poorly the Mini performs through the fiberglass of the Wrangler hardtop. When focusing on the most common type of vehicle used as of Mini subscribers who use the device for overlanding, the Jeep Wrangler is the most commonly occurring vehicle for trail-focused adventure travel. This means that SpaceX would be best interested in focusing their efforts here. ChatGPT states that Starlink can lose anywhere from 3 decibels to 10 decibels of signal when passing through the fiberglass roof of a Jeep Wrangler. In terms of statistical analysis, the likely model to use when categorizing whether a device is efficiently using the received signal would be logistic regression. Setting the parameters of the program to say yes when the Mini or other similar device has a signal loss of less than, say, 5 decibels, and no when the signal loss is more than 5 decibels when passing the signal through various barriers. Research on the exact composition of the Wrangler hardtop is limited, as this is likely a trade secret. Initial results indicate that the hardtop is manufactured out of a composite material consisting of fiberglass and of resin, which would explain the loss of signal or attenuation experienced inside of a Wrangler. SpaceX would need to determine where all of the various materials would come from for the creation of their new, more powerful receivers. Would the various components be made in-house, or would they outsource the needed components? Additionally, SpaceX would need to figure out if new satellites would be needed, and if so, where would they come from, or would they be manufactured in-house? Another thing to consider is the third-party market for vehicle mounting solutions, and if the market will be able to support a new receiver in a short amount of time. Will the new product be sold exclusively by SpaceX, or will third-party vendors be allowed to sell the new product as well? These decisions need to be mapped out and made prior to starting the manufacturing process to ensure the highest levels of customer satisfaction. When considering using AI for decision-making in daily life or in business, there are a few questions that one must ask themselves before committing to such a thing. First, one should ask themselves if they really even need AI to help them in this area, or if they need AI to take the helm completely. Second, the user must institute a set of checks and balances to make sure that AI is being used in an ethical manner. Some questions that need to be asked would be, is this hurting anyone? Is this hurting the company? Is this illegal, unethical, or immoral? These are just examples because the list of questions could go on. However, if these three questions can be answered in the negative, then it is probably safe to say that a decision made by AI is good to go. On the other hand, there may be times where a company needs AI to take the helm on a decision completely. These types of situations may arise when the decisions that need to be made happen far too quick and too often for the human brain to be able to comprehend. Take Starlink, for example. Starlink uses a vast array of satellites and receivers that work in conjunction with each other in a global network. These satellites are orbiting the Earth at incredible speeds, so they must constantly talk to each other so that they know which satellite needs to talk to which user at any given time. Now, obviously, there are not much ethical implications involved in this, but the algorithm has to be written in such a way that human hands and brains do not need to get involved once the system is put into play. This concept carries over to AI used in normal business operations, wherein AI has all the decision-making authority. The user must ensure that the algorithm is written in such a way that the decision does not harm anyone else or the company, and that decisions are not illegal, unethical, or immoral. So my recommendations would be to have stronger receivers, stronger signals, and better mounting options. The question here is what might be needed to make the Starlink Mini a better product, whether it be stronger receivers or stronger transmitters in the satellites. This question can truly only be answered through research and trial and error. Fiscally speaking, the most intelligent decision would be to redesign the receivers to make them more sensitive and so that they can pick up the transmitted signal through more barriers than just glass. New, more powerful transmitters would cost billions, if not trillions of dollars to implement, whereas the research for new receivers might only cost a couple of million dollars. The most common sense approach would be to completely redesign the Starlink Mini to make it more sensitive. Initial rollout should be done with a newer model Starlink Mini. Upgrades should be offered to existing customers at a discounted rate. As time progresses, higher power transmitters on the satellites should be implemented to complement the more sensitive receivers. The research and design of the new product would take a number of years and would likely cost a few $1,000,000. But that cost would eventually be offset by the potential profits from new customers who may have avoided the use of the Mini due to the limitations on mounting options. Projections would be quite promising for substantial profits for the company. In conclusion, using logistic regression and supply chain logistics, SpaceX should invest in the research and development of a new Starlink Mini design so that the receiver is much more sensitive and able to receive signal through more barriers than just glass and thin fiberglass. AI could assist in this process, potentially by designing the software and perhaps even the hardware that would be needed to create such a system.